Hello everyone. So today we are going to see a concept called tree traversal in data structure. So before getting into tree traversal, let us see a little introduction about data structure and the classification of data structure, and then let us move on to tree traversal. So what is data structure first? So data structure is a storage, or you can call it as a format for organizing, storing and managing or accessing the data from a data like in a structure. Okay, so this is called a data structure. Data structure is nothing but a structuring a data, organizing a data. Okay, and including like other than the organizing, you can call it as like it is used for accessing, retrieving and managing the data. So this is what data structure is. And next we move on to classification of data structure. So under the classification of data structure, it is being divided into two types. Like one is linear data structure, other one is non-linear data structure. So when the storage is like it has been broadly divided into two types. Like one is linear data structure and the other one is non-linear data structure. So linear data structure is a structure where the elements are stored in a sequence manner, okay, contiguous manner. And the non-linear data structure is, from the name you can identify that it is not stored in a sequence. Like say for example, under linear data structure, there is a structure called array, there is a structure called stack, there is a structure called queue and linked list. So these are the different structures under linear data structure. So non-linear data structure, it is not stored in a contiguous way. So the data structures used in under non-linear data structures are tree and graph. Okay, so let us see like little introduction about all these types. So what is an array? Array is a linear data structure where the elements are stored in a sequential manner. Okay, say for example, uh, I'll draw the structure of array here. Slide. Say for example, you have array structure where you can store like list of elements in a sequential way. It is indexed from 0. So the index starts from 0 and it goes on 1, 2, 3, 4, 5, 6. Now I have drawn a array data structure of size 7. Okay, so the index starts from 0 to 6. So this is called array data structure, and now you can store the elements inside each index. So you can store the elements inside each index. See, I can store 10, 20, 30, 40, 50, 60 and 70. You can store any elements, like it's not, it is array is a linear data structure which stores elements of similar data type. So you know about what is similar data type. If I am storing integer, it array stores only the integer. Okay, if you are going to store like decimal point numbers, it stores only the decimal point numbers. So you cannot mix the data types inside array data structure. Array can store only a single type of elements. Okay, so this is what array is. And next let's move on to stack. Okay, see, stack is also a linear data structure, okay, where you can store elements in a sequential. Okay, even in stack you can store the elements in a sequential way. I can store elements like 10, 20, 30 and so on. Okay, so like it has the index also, like it starts from 0. 1, 2, like, okay. This stack can be, so stack is nothing but it, there is a concept under stack, like see there are elements stored inside the stack, so stack will be initially like this, okay. So you can push the elements inside, there are some operations under stack, so you can insert the elements inside the stack at one end and you can delete the elements at the same end, okay. So I can insert from this end and I have to delete at the same end. So that is the concept of stack. So when I store elements, see, say for example, I need to store some 3 elements. Say for example, I need to store 10, 20 and 30. So first let me insert 10. Okay, so 10 will be inserted at the same end. Okay, and 20, and the second element 20, and the third element 30. Okay, now if I want to delete any element from the stack, you can delete only the last element first. Okay, the last inserted element can be deleted first in stack. Okay, so when you want to delete, you can delete 30. Okay, first you can take out, delete 30 and take out 20, delete 20 and take out 10 and delete 10. Okay, so there are these inserting element inside the stack is called push. Inserting element inside the stack is called push, and when you delete an element from the stack, the operation is called pop. Okay, inserting is called push and deleting an element from the stack is called pop. Okay, and next let us move on to the other data structure queue. So in stack, you know that elements are inserted and deleted from the same end. So the stack operations can be called as last in, first out, LIFO. We call it as LIFO. That is, last inserted element will be taken out first. So last in, first out. That is called stack operation. Next, let us move on to queue. So, you know, from the name you can like guess what a queue data structure is. Queue is also a linear data structure. Like you can example, you are getting, you can take an example like you are in a queue to get a ticket. Means it can be a railway ticket or any ticket. Okay, so you are in a queue. So the person who goes first will get a ticket and comes out first. Okay, the same thing, the concept under queue. See, when the element is inserted, okay, when the element is inserted, it goes, okay, it can be inserted at one end and the same element can be deleted at the other end. Okay, so insertion happens at one end and deletion happens in the other end. Okay, this is called queue, right? So when I want to insert elements inside the queue, you can insert elements from one end and you can delete the elements at the other end. So queue is called first in, first out structure. See, first in, the person who goes first will get a ticket and comes out first. So first in, first out structure. So queue is also a linear data structure. It follows the concept called FIFO concept. Okay. So next let us move on to linked list. See, under linked list, all these concepts are like you have their storage is fixed under stack queue. Okay, so I'll say for example, you can fix a size. The array can contain even an array. Okay, even an array, the storage is fixed. Say for example, I am going to store a 10 elements. Okay, like collection of 10 elements. I can assign the array of size as 10. Okay, only then you can store the elements. And the same way, stack can be implemented using, stack is a concept which can be implemented using array as well as linked list. Okay, so stack is a concept which if you want to implement using array, you have to specify a stack size before. Okay, in the same way, queue can also be implemented using array as well as linked list. When you are implementing using array, you have to specify the array size before. Okay. So linked list, what is the difference between array and linked list then? Array has a fixed size, okay, but in linked list you can the size can be increased then and there, so it is called dynamic. Okay, the linked list is dynamic because when you want to insert an element, you can increase the size of the linked list. Okay. So linked list is a, for each element you will consider a node. Okay, so say for example this is a node for storing a single element. Okay, so for single element there are two segments, one is data segment, the other one is link segment. Okay, under data segment you can store the element. Say for example if I need to store the element 10, it stores 10. And under link segment you can store the address of the next node. Okay, address of the next node where I want to move. Okay, so this is the address of the next node, right? So in each node will have a two segment. Okay, one is for storing the data, the other one is for storing the next node's address. Okay, so what contains like the last node, this is the last node. Okay, so the first segment will store the data. So what does the other segment contains? It contains the null pointer. Okay, or you can call it as null value, right? So this is how linked list looks like. So I'll recap. See, there is in linked list there are for storing each element. For storing each element, there are two segments, like data segment and the link segment. Okay, so for data segment, under data segment you can store the element. Under link segment you can store the next node's address. So this carries on for each node. Okay, under each node you will store a single element. And for the last node, it contains, like it doesn't have the next node in order to point, like the next field cannot point to the next node because this is the last node. So it contains a null value. Okay, let's move on to, these are the introduction about linear data structure. Okay, so under linear data structure, the elements are arranged in a sequential way. So see, under array linear data structure, we have learned what is array, stack, queue and linked list. So now let's move on to non-linear data structure. So non-linear data structure, from the name you can guess that non-linear data structure, under non-linear data structure the elements are not stored in a linear way, sequential way. Okay, so first let us take a tree structure. So under tree structure, the elements are stored as a tree. See, which has a hierarchy structure. The tree will be like nodes are stored in a hierarchical manner, and it contains a parent-child relationship. Parent-child relationship. Okay, so under tree structure, the elements are stored in a hierarchical manner and it contains a parent-child relationship. What is parent-child relationship? When you have a single element, from where you are going to start, you call that element as a root element. Say for example, I am starting, whenever I need to access the tree, I have to start with 1. So this is the root element now. Okay, so this is the root element. The root element has subtrees, left subtree and right subtree. This is the root element and this is the left subtree and this is the right subtree. Okay, now there is only 3 nodes. There are only 3 nodes. So from the root element, if you consider, this is the parent element. Okay, this is the parent node, and under this you have left subtree and right subtree, under which you have only one node, that is 2 and 3. Okay, so 2 and 3 are called child nodes for the parent 1. Okay, so this is how a tree structure will be. Tree is a hierarchical structure where it carries out the parent child relationship. So the next, this is a like small introduction about tree, and next you have a graph structure. So under graph structure, the nodes are interconnected like a network. Okay, the nodes are interconnected like network. Okay, so each node will be interconnected to the other nodes. Okay, you can specify a source node and a destination node, and you can start with the source node if you want to traverse the graph. Okay, if you want to visit the nodes, you can start from a single node, right? So this is how graph looks like. So in each element is stored as a network structure in under graph. So that's all about a small introduction about classification of data structure. So under classification of data structure, we have seen linear data structure and non-linear data structure. So under non-linear structure, there is a structure called tree. So this is a concept. Under this tree concept, we are going to learn what is tree traversal. So tree traversal, let me tell you the definition for tree traversal. See, tree traversal is a process of traversing or visiting, okay, or exploring nodes in a tree, okay, in a tree in a specific order. Say for example, I have a tree structure like this. So I have a tree structure like this. See, one is a root node and this is the left subtree. One is a root node. This is the left subtree and this is the right subtree. This is the right subtree and this is the left subtree. So tree traversal is the process of visiting or exploring each node in a tree, in a specific order. Okay, in a specific order. You can under tree traversal, there are a number of orders in which you can traverse the tree. Okay, so this is the root node, a left subtree and right subtree. So tree traversal has been classified into two types. Tree traversal has been classified into two types. One is DFS, which is called as depth first search, and the other one is BFS, which is called breadth first search. Okay, so let me tell you what is DFS and BFS. Okay, now what is DFS? It is called depth first search. So let's take the same example now. See, 1, 2, 3, 4, 5, 6, 7 are arranged in a tree structure. Okay, arranged in a hierarchical structure. So under this is DFS search. You know what what is DFS? A depth first search. Depth first search is exploring each node in a tree in a specific order. That is what is tree traversal is. What is depth first search then? Exploring each node, okay, each node in a tree in a specific when you complete a single branch, you have to move on to the other branch. Okay, so when I want to visit a node, I need to complete a particular branch of that node first, and then I have to move on to the next. Okay, say for example, see, DFS is depth first search. So I'll start with the root node. So this is the root node. I'll start with the root node. I'll visit one now, and then which is like 2 is one branch and the 3 is an other branch. So this is left subtree and this is right subtree. So I can take like I can take left subtree. So after visiting 1, I'm visiting 2. Okay, after visiting 2, like 2 has 2 branches, 4 and 5. Visit 1 branch first. So the branch of 2 is 4. So I have completed this, and then I'll check for the branches of 4. There are no branches. So I have to go backtrack and go to the other sub branch of 2, and I have to visit 5, and this branch is completed. Now move on to the next branch. That is the other branch, which is 3, and from this you have 2 branch, 6 and 7. Go for 1 branch like 6, and then there is no branches for 6. So backtrack, go for the other branch of 3, that is 7, visit 7 and complete the tree traversal. So tree traversal is a process of visiting a node at least once. You have to visit at least once in a specific order. So in a specific order, that order means it has been classified into DFS and BFS. So depth first search, you have to visit a particular branch, like you have to visit all the nodes in a particular branch completely, and then go on to explore the second branch of DFS. Okay, under DFS. So second branch of a tree, then you can visit. Okay, this is called DFS. So what is BFS then? Breadth first search. What is BFS then? I'll take the same example. The tree contains the nodes 1, 2, 3, 4, 5, 6 and 7. Okay. So what is breadth first search then? Breadth first search is like you have levels in tree structure. Okay. So this is level 1, and these 2 nodes are under level 2, and all the other nodes under level 3. Okay. So in a tree structure, the hierarchy levels, okay, in each level, okay, this is called a level. So root is in first level, and the other 2 nodes like subtree, like subnodes of 1 and 2 are the other level, next level 2 and 3, and the subnodes of 2 and 3 are in next level, level 3. Okay, so these are the levels. So under BFS, you have to complete a level and then move on to the next level and then move on to the next level. Okay. So under BFS, you will visit the root node first, 1, and then under 1, you have 2 and 3 in the next level. So complete the next level, visit 2 and 3, and then move on to the next level, complete visiting 4, 5, 6, 7, complete this level, and then move on to the next level. Okay. So this is how breadth first search works. Okay. So DFS is visiting a complete branch of a tree, okay, and then move on to explore the next branch of a tree. But BFS is complete a level and then move on to the next level. Okay, complete a level, move on to the next level, complete a level, move on to the next level. So this is how BFS works, breadth first search works. Okay, so these are the main 2 tree traversals of a tree, BFS and DFS. And under DFS, and I forget to tell you that BFS is also called level order traversal. Okay, since it follows the level, completes a level and moves on to the next level, it is called a level order traversal. Under DFS, you have under DFS there are 3 types. There are 3 types under DFS tree traversal. It is in order tree traversal, pre-order tree traversal, and post-order tree traversal. Okay, These are the three types under DFS. So let's see these three traversal one by one. Now, so first let's see what is in order traversal. Okay. See, all these are types of DFS. This is also a tree traversal. So, how this in order traversal happens is, I'll give you an example. You will better understand from that example. So, let us take the same example where the tree contains 1, 2, 3, 4, 5, 6, and 7. Okay. So, under in order traversal, remember this, like in order in the sense, first it visits the, first it visits the, visit the left subtree, and then it completes the left subtree, and then moves on to the root element, and then it visits the right subtree. Okay, so this is how in order traversal works. First it visits the left subtree, okay, and after visiting the left subtree it has a node, and if the node has the subtree, it follows the same, it follows the same order of in order, okay, and then it visits the root, and then it completes the right subtree. Say for example, this is the root node, so I have to traverse from the root node. So let us write the in order traversal for this tree. Okay, the in order traversal for this tree is, so it visits the root node. Will it visit the first, root node first? No, it has to visit the left subtree. So it starts its traversal from the root node. So it starts from 1. So it is not like this node is not the visiting node right now, because it has to go to the left subtree. So it goes to the left subtree. Okay, it goes to 2 first, and it checks. 2 is also a parent of 4 and 5. Okay, again it goes to the left subtree, okay, which is left subtree, like under 2 it is 4, and 4 doesn't have any branches, this is a leaf node. So 4, it visits the left subtree, this is the last node, so it visits 4 first, okay, and now consider this as a part of a tree, okay. So this is parent and these are child nodes 4 and 5. So it visits the left subtree, that is 4, and parent 2, and then right subtree 5. So 2 and 5. Now I have visited this 4 left, root, right. Completed this left subtree, and then I have completed the left subtree of 1. Now I have to visit the root 1. Okay, 1 is completed. I have to move on to the right subtree now. So right subtree is this. So go to 3. 3 is not a left subtree. Again traverse to the left. Okay. So 6, it is the last leaf node. So traverse 6, and then root, and then right, which is 7. So this is a in order traversal for this specific tree. So in order traversal is 4. So this is a tree. So I'll repeat this. So this is a tree. See, from the root I have to take the traversal. So I have to visit a node at least once. So it starts here. So in order traversal is nothing but first I have to visit the left node, right, root node, and then right. So first visit the left subtree. So 2 is a left subtree of 1. So it goes to 2. Again it checks. This is a root node. So again traverse to the left node. So 4 is the left, and then move on to the root node, which is 2, and then traverse to the right subtree, which is 5. Okay. So 4, 2, 5. I have completed the left subtree. go to the root, which is 1, again go on to the right subtree, which is 3. Okay, 3 has sub branches, so move on to the left branch. 6, no more branches for 6, so visit 6 and then move on to the root 3 and then move on to the right subtree, which is 7. Okay, so this is the in order traversal for this specific tree. Okay, so this is how in order traversal happens. So what is pre-order traversal then? Let's see what is pre-order traversal now. Let us consider the same tree. So pre-order traversal is first it visits the first it has to visit the pre-order means the root has to be visited first. So first it visits the root and then it visits the left subtree and then it goes on to the like it explores the right subtree. Okay, so first visit the root under pre-order traversal. It visits the root first and then it moves on to the left subtree and then it goes to the right subtree. So let us write the pre-order traversal for this specific tree. Okay, so pre-order traversal is like I have to visit the root first and then I have to go on to the left sub branch and then I have to move on to the right sub branch. Okay, so which is the root here? So if I have to start from the root, so which is the root here? 1. So I'll visit the root node first. Now next, which is the left subtree? 2 is under left subtree of 1 and 3 is under left subtree of 1. I have to visit the left subtree first and then move on to the right subtree. So I'm moving on to the left subtree. Now I'm considering this as a tree, which is parent no root node now. This is 2 is the root node. So I have to visit the root first. Okay, 1 is completed, root first and then I have to move on to the left subtree and right subtree. Left subtree is 4 and then I have to move on to the right subtree, like which is 5. Okay, if this 4 has again like sub branches, it completes this and then I have to move on to 5. Okay, so now I have visited 1, 2, 4, 5. This side is over. Okay, I have visited root left subtree. Now I have to move on to the right subtree of this. So right subtree of this is 3. This is the root node. When I consider this as a tree, this is the root node. So visit 3 and then left subtree and then right subtree 7. Okay, 6 right left subtree and then right subtree is 7. Okay, this is the pre-order traversal for this specific tree. So you have to traverse the root, move on to the left subtree. Again, this is a root, so move on to the left subtree. This is a final node, like leaf node. So visit root and then left and then right. So this is how traversal happens under pre-order traversal. Next, let's move on to post-order traversal. Let us consider the same example, like same tree as, let us take same tree as example. So post order traversal. Okay, so post order traversal, I'll take the same tree as an example. So under post order traversal, it has to visit the left subtree first and then right subtree. I have to visit the left subtree. I have to complete the left subtree and then I have to visit the right subtree and then I have to visit the root node. So this is how traversal happens in the post order traversal. So post order traversal is like you have to first complete visiting the left subtree nodes, and then I have to complete visiting the right subtree nodes, and I have to complete the root node. Okay. So let us write the post order traversal. Post order traversal for this particular tree. So in this I have to visit the left subtree, right subtree, and then root. So from the root I have to start my traversal. So this is the root node. Okay. So this is the left subtree and this is your right subtree. Now I have to start traversing the left subtree. I have to complete left and then right and then root. Okay. So I'm coming here. Consider this as a tree. Now this is the your root. Go to the left subtree, which is 4. Does it have branches? No. This is the last node. So complete visiting 4. I have visited 4. Left subtree is over now. Move on to the right subtree, which is 5. Visit this 5. And then left subtree is over, right subtree is over. I have to move on to the root, which is 2. Like I have visited 2. Okay. Now left subtree, right subtree, root is over. Now this is the left subtree for 1. Now left subtree is over. Now I have to move on to the right subtree, which is here. This is your right subtree, and from here, if you take this part, this is the root and these are the child nodes. So this is left subtree of this parent and this is the right subtree of this parent. I have to complete left subtree and then right subtree and then I have to move on to the root node. So I have completed my left branch and then I'm moving on to the right branch. Under right branch, this is a part of a tree, this is a root node and this is left subtree and this is right subtree. Complete your left subtree first, which is 6. I have visited 6, and complete your right subtree, which is 7. I have visited 7, and then left subtree is over, right subtree is over. Now move on to your root node. So your root node is 3 now. Okay. Now I have visited 3. Now in this tree I have completed my left subtree. I have completed my right subtree. Then I have to visit the root. Now visit the root node 1. Okay. So this is how post order traversal happens. So let me give a recap of these 3 tree traversals. Like under tree traversal is a process of visiting each node at least once in a specific order. So there are 2 particular types of like tree traversal, which is DFS and BFS, depth first search and breadth first search. Breadth first search, there is no specific like types of BFS. You have breadth first search, which is level order traversal. Okay, and we'll see how level order traversal happens and the list of nodes and level order traversal. So depth first search, there are 3 types, which is in order, pre-order and post order. And in order, the tree traversal happens like you have to visit the left first, root and then right. Okay. And a pre-order traversal, you have to visit root first, left and then right. And post-order traversal, you have to visit the left, right and then root. Okay. So under post order traversal. So these are the 3 different types of tree traversal, and under BFS, like which is called a level order traversal. Let me give you like example tree. I'll give you the traversal of breadth search as well. Okay, I'll take the same tree as example for breadth search also. Breadth search is also called a level order traversal. Okay, so I'll take the same tree as example, which is 1, 2, 3, 5, 6, and 7. Okay, now I have to write the level order traversal. As you know, breadth search carries out its traversal level by level. right? So it carries out its traversal level by level. So this is a single level, and this is under second level, and this is under third level. So it completes level 1, and then it goes on to the next level, and it visits the nodes level 2, and then it moves on to the next level, and it visits all its nodes. Okay. So what is the breadth first search for this particular tree? The level order traversal for this tree is it completes the first level, which has only one, okay, one node, which is root node, and it goes on to the next level which has 2 and 3. So visit 2 and 3 and move on to the next level, which contains 4, 5, 6 and 7. So visit node one by one. That's all. So this is level order traversal. So level order traversal for this particular tree is 1, 2, 3, 4, 5, 6, 7. So let me conclude this. Okay. Let me conclude this tree traversal right now. Thank you so much for watching. Thank you.